before we get to example 2, I'll call this one example 1.5. Sure. It is evaluate. You can do this just at the top of page 655. Evaluate two times sine of pi over 12 times cos of pi over 12. What does this trigger inside of you?
It triggers that you simplify.
Okay. What else does it trigger for people?
Oh, it's
The pi over 12 stuff? Does that trigger the pi over 12? You see the pi over 12? Okay. At the end of the year, your pi over 12 trigger in this question will be really strong because you've done pi over 12 questions, pi over 12. So you've got your strategy because we did it yesterday for pi over 12 questions. If, just a second, if we did our pi over 12 question, we'd have to do it for sine, and we'd have to do it for cos, and then we'd have to multiply all those answers together to get our final answer. Usually a pi over 12 question's worth 3 marks, so that would mean figuring out sine of pi over 12 would be 3 marks. Figuring out cos of pi over 12 would be another 3 marks. Multiplying them together, if I wanted you to do it that way, I would make this question a 7-mark question. Had we got this as a take-home quiz yesterday, it would be a 7-mark question. Now this has been on the final exam. Sometimes it's a 1-mark question, sometimes it's a 2-mark question. That means there must be a better way to do it if it's only out of 2 marks. And it's to be able to say, I've got my other formulas memorized too, and I recognize my 2 sine theta cos theta formula show up. Can you see that that's the right-hand side of your double angle identity for sine? Sine 2 alpha is 2 sine alpha cos alpha. So that means if alpha is my pi over 12, then I can rewrite this as sine of 2 times pi over 12. And does that simplify? Sine of pi over 6. And that's equal to 1/2.
You just done sine of bracket pi over 12 plus pi over 12 is simplified.
Well, 2 times pi over 12 is pi over 12 plus pi over 12, but this is the best way to go about it as far as it doing as short as possible. So that's how you would do it if it was a 2-mark question. But some questions that we have will cause you to have 2 different triggers. This one can trigger your pi over 12 questions, and it can also trigger your double angle identities. So you have to be aware of that sometimes. Maybe sometimes you're working on a question, you're like, this is not going well. This is getting too complicated, too big. Maybe I need to step back and look at the question at the beginning and see if it triggers something else for me. And I often do this with questions. If I'm doing a complicated math question, I'm like, okay, this is what my gut tells me I should do. And I start with that. And when it gets really messy, sometimes I stop and go back and look at the question again and say, is there a better way that I could go about this? And sometimes I spend 10 minutes looking for a better way to find nothing. And then I go back to my complicated way and I say, okay, I've got to continue with this complicated way for now and work on it. And then if it begins to frustrate me more because it gets too complicated, I go back to the beginning again. Okay, there's got to be a better way. And I look at it again. And I go back and forth and back and forth. And sometimes problems like this for me in mathematics, end up lasting hours, days. I have some that are still on the shelf, simmering for years, that I haven't solved yet. But at any moment, I'm like, okay, maybe I should go back and see if I can figure that.
Is there on Wikipedia's unsolved calculations?
No. And there's always the temptation. I could look online and there would be a proof that would show it to me, but I wanted to figure it out on my own.
Make sure it's not an unsolved question.
Well, I know that for the ones that I'm working on, some of them I know that they're solvable.
Okay, good.
So,
All right, so you're not being-
so I just haven't figured them out yet. So here is example 2. Part A, it says write each as a single trig ratio and evaluate where possible cos squared minus sine squared of pi over 4. Okay, tempted to say 1, right? When can we say it's equal to 1? If it was a plus sign. Because our formula says cos squared theta plus sine squared theta is 1. But it's a minus sign. So look a little bit further on your formula sheet. Does that appear anywhere else? If this is my alpha and this is my alpha, do I have a cos squared alpha minus sine squared alpha somewhere? Yes. It's equal to cos of 2 alpha. And when I simplify that, that just becomes cos of pi over 2, which is 0. Now this is using the identity. In some ways I don't like this question for what they're trying to do because pi over 4 is already on your pi plate. So if someone asked you to evaluate that, what is cos of pi over 4? What's cos of pi over 4? Root 2 over 2. So you might have said, well, I know that cos of pi over 4 is root 2 over 2. So cos squared will be root 2 over 2 squared. I know that sine of pi over 4 is root 2 over 2. So sine squared will be root 2 over 2 squared. And this minus this, well, they're identical, is going to equal 0. So you missed the whole point of this question, except for the fact that they said write it as a single trig ratio. But if the question said evaluate, this isn't very helpful. So these questions are nicer if I rewrote A. Oh, we already did a 1.5. Are you okay if I do an A.5? Okay, question A.5 is going to look a lot like question A, but I'm going to do cos squared of pi over 8 minus sine squared of pi over 8. Okay? Pi over 8 is not on our pi plate. 22.5 degrees. But if you recognize this is your alpha and alpha this time, you get cos of 2 times pi over 8, which becomes cos of pi over 4, which is root 2 over 2. So that one you could only evaluate if you used your double angle identity. Whereas part A, you could figure it out both ways. Okay? Same thing for part B. For part B, you know tan of pi over 6. You could plug that in and solve it. It's going to be a little bit messy because you'll have fractions inside of fractions, and the simplifying isn't going to be nice. But one thing that you might have already memorized with your sum and difference identities is that if you have a fraction with a bunch of tans in it, you should check your formulas, right? You probably don't have them memorized. The tan formulas, I can honestly say, even though I've taught this for 15 years, the tan formulas, I haven't really ever decided to really memorize them. I just recognize, oh, I got a whole bunch of tans in a fraction. I better look up there on the board and see if it matches something. So in this case, if this is alpha and this is alpha, does it match up perfectly? No, it doesn't. Can you see that it doesn't quite match up perfectly? The top matches up, 2 tan alpha, because here's our, just so that we have it in our notes here, I'll erase this on this side. I'll try to erase it again. Here's our tan 2 alpha formula. It says 2 tan alpha over 1 minus tan squared alpha. Are we close with our formula? Yes. But the bottom is just the flip. So if we take this and on the bottom factor out a negative, that's the same as this whole fraction, right? A negative on the bottom of a fraction or a negative on the top of a fraction, that's like having the entire fraction negative. And so this is equal to negative tan of 2 times pi over 6, which simplifies to pi over 3, and you know that value from your pi plate. Still was a fair bit of work with the manipulation, so again, in this one, you might have preferred just to plug in root 3 over 3 for tan and try to simplify it. No, it's not. It's badly written. I'm sorry. It's tan squared of pi over 6. Okay, questions 4, 5, and 6 for this one, and we will do one more example